In this next video, we're going to look at how to solve trig equations when you have multiple different trig functions. We've done problems like this, but none of them have been squared or they've been able to be factored out easily. In these next videos, we're going to look at problems where one of them is squared and one is not. Whenever we have a trig function that's squared and one that is not squared, we need to convert the squared trig function into the other trig function. So for the first problem we're going to look at, we're going to find all the solutions of 2 cosine squared minus sine of x minus 1 over the interval 0 to 2 pi. So if we look at this, we can see that we have a cosine squared here and a sine of x here. And the problem with this is we can't factor out a cosine from everything because not every term has cosine. And we can't factor out a sine from everything because not everything has sine. We also can't break this down into factoring like this, how we did in the previous examples, because if I made this a more simple problem, it'd be like 2x squared minus y minus 1 equals 0, because sine and cosine are two different variables. So the first thing I like to do is just rewrite the problem down, and then we need to turn one of our trig functions into the other. Well, we know we have an identity that goes with cosine squared. So recall that sine squared plus cosine squared is equal to 1. So if we subtract sine squared from both sides, we get cosine squared is equal to 1 minus sine squared. So cosine squared is going to go in, and then as a result, what's going to come out is 2 times 1 minus sine squared minus sine of x minus 1, which equals 0. So the cosine squared went in, and a 1 minus sine squared came out. A quick side note that I'd like to make is that it is hard to change a trig term that is not squared. It is much easier to change trig functions that are squared, because we have the Pythagorean identities. At this point, we can now just go ahead and solve this problem like we did in the previous problems. So we distribute the 2. We get 2 minus 2 sine squared minus sine of x minus 1 is equal to 0. We're going to go ahead and combine our like terms, and I get negative 2 sine squared minus sine of x plus 1 is equal to 0. And then I'm going to go ahead and do the trick where I'm going to let u equal sine squared again, just to make my factoring a little easier. So I get negative 2u squared minus u plus 1 is equal to 0. And then from here, I want my leading coefficient to be negative 1, so I multiply both sides by negative 1. And I get 2u squared plus u minus 1 is equal to 0. And now I can go ahead and factor. So I get 2u, a u, a 1, and a 1, a plus, and a minus. So now I set both those equal to 0 using the 0 product property. And I get u is 1/2. And u is negative 1. So here I get sine of x is equal to 1/2, and sine of x is equal to negative 1. And sine of x is equal to 1/2 at pi over 6 and 5 pi over 6. And sine of x is equal to negative 1 at 3 pi over 2. And so my answers are just pi over 6, 5 pi over 6, and 3 pi over 2. Okay, so for the next example, I want to find all the solutions of cotangent squared, cosecant squared, plus 2 cosecant squared minus cotangent squared equals 2. Okay, so the first thing I like to do is go ahead and rewrite down what my function is. Okay, so I'm going to subtract the 2 from both sides. Okay, and now if I look at it, I can factor by grouping. So in my first 2 terms, they both have a cosecant squared in common. So I can go ahead and factor that out. So I'm left with cotangent squared plus 2. And then in my second 2 terms, I can factor out a negative. So I factor out a negative 1, and I'm left with cotangent squared plus 2. And now both terms have that cotangent squared plus 2 in common, so I can factor that. Cotangent squared plus 2 times cosecant squared minus 1. And I set that equal to 0. And now using the zero product property, I can set those both equal to 0. So for cotangent squared, I'm going to subtract 2 from both sides and then take the square root. So I get cotangent of x is equal to plus or minus the square root of negative 2, which of course we cannot take the square root of a negative number, so there's no real solution to this part. And then for cosecant squared, we're going to add 1 to both sides and then take the square root again. So you get cosecant of x is equal to plus or minus 1. So this is going to become two problems now. Cosecant of x is equal to 1, and cosecant of x is equal to negative 1. So if you can't remember how cosecant works, it's 1 over sine. So sine is equal to 1 over 1. You take this and it goes into the denominator. And 1 over 1 is just 1. So sine of x is equal to 1 at pi over 2. And then for negative 1, you do the same thing. So sine of x is equal to 1 over negative 1. And 1 over negative 1 is just negative 1. So x is equal to 3 pi over 2. So my final answers to finish off this problem is pi over 2 and 3 pi over